Hello everybody. Today we will be going over adding and subtracting using laws of exponents. So first I want to break down exponents for you. So pretty much what exponents are, they signify how many times a number is being multiplied by the same number to get a number. So say if I were trying to get 25 with 5. So instead of writing out 5 plus 5 plus 5 plus 5 plus 5, or doing 5 times 5, I can do 5 to the second power, because the 2 signifies how many times I'm multiplying 5 by 5. So I multiply 5 times 5, and that would give me 25. Okay? Instead of writing down 5 plus 5 plus 5 plus 5 plus 5, I can go down from that to this, and I can go from this to that. This is the simplest form whenever it comes to getting this. Another thing I would like to go over before we get into the main thing is that I would like to go over what the coefficient is, and what the exponent is. Okay, so right here we have the coefficient. And right here we have the exponent. So what is being added here is not the exponent. We are going to add the coefficient. So the only way the coefficient can be added together is if in the equation, if the exponents are like the same last name rule. So this will equal to be 10x to the second, because we have like exponents. Something else you should think about when you are going and solving on problems like this is when you have just x. Say if I had just x to the third plus 5x to the third, just because there's a number right here does not mean it is 0. So if you have 1x, the x is there for a reason. So the 1x signifies that it is 1. And the 5 signifies that there's 5 x's. Instead of writing out 5 x's, you have the 5 and the x. Okay, this is fairly simple, so you should probably be getting the hint by now. So, say if we had an example with the letter M. So if I had m to the third plus m to the third, you should know that because this is empty, that's 1, and that's 1. So with this equation, you should get 2m to the third. Or say if we had an equation like this. The first thing you should be thinking about, is there a number right here? The answer should be yes, because that is 1. So that'll be 1m plus 15m, get you 16m to the fifth. So pretty much what you should be thinking is you can disregard the m and the 5. All you have to do is think about the number. The number is what you pretty much have to add, and at the end you can add the m and the 5, which is the coefficient and the exponent. So you're going to get 16 m to the 5 because you're pretty much just adding 15 plus 1. Okay, let's try another one. So let's say if I had 5z to the 6 plus 7z to the 6. The first thing you would do is check and see if your coefficients and your exponents are the same. So as you can see, I have my 6 and my 6, and I have two of my z's, which are the same. So you can automatically go ahead and write down z to the 6 because we have that, this, and that. And then the next thing we would do is see what our numbers are. We have 5 and 7. So 5 plus 7, you know, is 12. So you would have 12 z to the 6. Okay, so now we're going to go over subtraction. And the thing about subtraction is it's the same thing as addition, but we're going to be subtracting, obviously. So let's use another problem like 15t to the third minus 11t to the third. Now the first thing we would do is look at our exponents. We're going to look at our coefficients and check and see if they're the same. So you can see our exponents are the same and our coefficients are the same. So we can go ahead and write this down on the bottom. We have t to the third. So what we're going to do here is subtract 15 minus 11, which is going to give us 4. So we will end up with 4t to the third. It's fairly easy, fairly simple, just like the addition problems. So let's go ahead and try another one. So let's say if we had 20m to the 5th minus 15m to the 5th. What do we do first? That's right, we would check our exponents and check our coefficients. They correspond. Then we write that down at the bottom, m to the 5th, and we would subtract 20 minus 15, which would give us 5. So then we would go ahead and write our 5 next to our m to the 5, and that would be our final answer. Let's go over another subtraction problem. Get practice perfect, make you better. So let's say if we had 8t to the third minus 7t to the third. First, you got to check all your parts. You got to check your exponents. You got to check your coefficients. They match. So we're going to bring that down. But the thing about this problem is that if you subtract 8 and 7, you get 1. So you could have two different types of answers. You could have t to the third, or you can write the 1 in front of the t, and it'll be the same exact thing. Like I talked about in the addition problems, when you have m to the third plus m to the third, that will get you 2m to the third. Just because there's nothing in front, that doesn't mean that there's nothing. That means that there's 1 and 1. So you're going to be adding 1 plus 1, or you're going to be subtracting 2 minus 1, depending on what is in front of your coefficient. Okay, since we're going towards the end of the video, I wanted to do a little bit of a challenging problem. I wanted to do a perimeter problem. Okay, let's act like this is a rectangle. So let's say if we had 2x to the third right here, 3x to the third, 3x to the third, and 2x to the third. What we would do is, first step, check our coefficient and our exponents. So all of it matches. We have our x's and we have our 3's for our exponent. So we write that down at the bottom, x to the third. And then after that, it's fairly simple. We could just go ahead and add all of our numbers. So we have 2 3's and we have 2 2's. So we have 6 plus 4, which is 10. So we have 10x to the third. Thank you everybody for watching, and thank you for your time.